Let's take a look at question 16. So these 6 points A, B, C, D, E, F, each of the point is assigned to a number from 1 to 6. So the digits along each line, they are added together to produce 5 sums. The total of these 5 sums is 47. So let's check for A, how many times is A added? So A is included in this straight line and this straight line. So A is added twice, we have 2A. Then for B, so 1, 2, 3 is either in 3 straight lines. So this is plus 3B. Then for C, this is 1, 2, either in 2 straight lines, so 2C. For D, 1, 2, so 2D. Then for E, this is 1, 2, 2E. For F, this is 1, 2. F is added twice, so 2F. Total is 47. So notice except for 3B, everything else is added twice. So we can get, you take out 1B, then the others are A plus B plus C plus D plus E plus F is equal to 47. So the total from A to F will be the total from 1 to 6. So you add these 6 numbers together. This equal to 21. 21 times 2 will be 42. So B plus 42 equal to 47. B equal to 5. So the answer is E. Question 17. So how many factors of the number 2020? They have more than 3 factors. First, we factorize the number 2020 divided by 2 equal to 1010. Then divided by 2, 505. Divided by 5, 101. 101 is a prime number. So divided by 101 equal to 1. So factorize this number, we get 2020 equal to 2 squared times 5 times 101. Okay, they're looking for the factors that have more than 4 factors, more than 3 factors. First, we look at the number that have 4 factors. So 4 factor, this is 2 times 5. This number, so to find the number of factors, this is 2 to the power of 1, 5 to the power of 1. So the number of factor will be 1 plus 1 times 1 plus 1. 4 factors. So 2 times 5 have 4 factors. So 2 times 101 or 5 times 101. These 3 numbers, they have 4 factors. Next, we have a number that have 6 factors. So this is 2 squared times 5. Okay, so the power term, this is 2, this is 1. So 2 plus 1 times 1 plus 1. 3 times 2, there are 6 factors. So the next is 2 to the power 2 times 101. And we also have number that have 8 factors. This is the number 2 times 5 times 101. This is to the power of 1, to the power of 1, to the power of 1. So the power term plus 1 multiplied together. 2 times 2 times 2, there will be 8 factors. The last is the number itself. It has 16 factors. Sorry, not 16, 12 factors. So it's the number 2020. You look at the power term, this is 2, 1, 1. So 2 plus 1 is 3. 3 times 2 times 2 equal to 12. There will be 12 factors. So let's check how many numbers are there. 1, 2, 3, 4, 5, 6, 7. 7 numbers in total, so the answer is B. For question 18. So this shaded region is not a square, this is a rectangle. So it's not 16 times 16 equal to 256. That's the wrong answer. To solve this question, we need to find out the length of CD. So what we can do is we find the center of the semicircle. We let this point be P. Then after that, we connect the center to the point C. So DP will equal to AP, equal to half of AD, so 16 divided by 2, equal to 8. Then we know that PF is the radius, so 8 plus 9, 17. PC is also the radius, so PC is 17. So now we focus on the triangle DPC. This is a right angle triangle. So use Pythagoras theorem, CD squared equal to PC squared minus PD squared. So equal to 17 squared minus 8 squared. This is 289 minus 64 equal to 225. 225 is 15 squared. So CD will equal to 15. So for the rectangle ABCD, the length AD is 16. The breadth CD is 15. 16 times 15. The area is 240. The answer is A. Question 19. So a number is called flippy if the digits alternate between two distinct digits. How many 5-digit flippy numbers are divisible by 15? Divisible by 15 means it's divisible by 5, also divisible by 3. So divisible by 5, the last digit is either 0 or 5. But in this case, it cannot be 0. If it's 0, the first digit is 0. So this is wrong. So the last digit can only be 5. This way is a multiple of 5. We let the two missing digits be A. If a number is divisible by 3, divisible by 3 means the sum of digits is a multiple of 3. So we have 5 times 3 plus 2A. This is 15 plus 2A. This is a multiple of 3. 15 is already a multiple of 3, so we need 2A be a multiple of 3. So A can equal to 0, 3, 6, or 9. So there are 4 numbers, 50505, 53535, 56565, and 59595. 4 numbers, so the answer is B. Question 20. So there's a scientist. He walked through a forest and recorded down as integers the heights of 5 trees. Okay, so take note here. So all 5 trees, the height is a whole number. She observed that each tree was either twice as tall or half as tall as the one to its right. So they want us to fill in the missing data here. First, we can figure out that tree 1. For the height to be a whole number, it cannot be 11 over 2. 11 divided by 2, this is 5.5. So that's not a whole number, so it can only be 11 times 2. This is 22. Then for tree 3, this one by the same rationale is 11 times 2, 22. It cannot be 5.5. So now for 4 and 5, there will be 3 possibilities. First one is tree 4 is half as tall as the third one. So 22 divided by 2 is 11. Tree 5 is twice as tall as tree 4. So 11 times 2, 22. So we find the average height here. We add all 5 of them together. 22 plus 11 plus 22 plus 11 plus 22. Then divide by 5. Divided by 5, this is 17.6. So this is not one of the answer. This one is wrong. The second case is tree 4 is twice as tall as the third one. So 11 times 2, 22 times 2, 44. Twice as tall as the third one. And for tree 5, twice as tall as tree 4, so 44 times 2, 88. So for the average, we add all 5 of them together. Then divided by 5. This time round, it equal to 37.4. This is also not one of the answers, so this one is wrong. The last case is tree 4 is 44. For tree 5 is different. Tree 5 is half as tall as tree 4. 44 divided by 2, this is 22. So we add all 5 of them together, divided by 5. This equal to 24.2. So the answer is B.